Hey, AP Calculus students, Mr. Meunier back here again today. Today we want to quickly run through what is the product rule. Product rule is powerful and different. This is what we use when we're multiplying terms together. So again, product rule basically helps us find derivative when multiplying terms together. Find derivative when multiplying terms together. Hence, product means multiply. Key thing is a term has a variable with it. Term has a variable with it. What we don't need the product rule for is something like this. People start to get confused. 3x squared is not a product rule. I know that's 3 and x, but really we have a number 3 and an x squared piece. There's only one group of variables in 3x squared. That is not a product rule. I don't need it. That's just going to be 6x from our power rules. 2x is not a product rule. 2 and x, I know you're multiplying, but there's only the one variable of x. That derivative is just the number 2. Product rule would be something like, well, we'll get to it here, but like x times cosine x, where you have an x, but then a cosine of x. So 2x pieces, all of this is multiplied together. That becomes a product rule problem, okay? And if that happens, if I want to take the derivative, again, this d dx means find the derivative of f of x times g of x. Again, notice we have an f of x and a g of x. Two things, they both have an x involved. They're multiplied together. We do that by finding the derivative of the f part, the first part, f prime, multiply that by the second part, plus, always a plus sign, the derivative of that second part multiplied by the first part. Derivative of first times second plus derivative of second times first. Derivative of first times the second plus derivative of second times the first. That's how we work this thing out. Derivative of the first part times the second plus the derivative of the second part times the first. Or you could do it the other way around. Derivative of second times first plus derivative of first times second, because the order in which you multiply items never makes a difference. So again, key thing is it's a multiple, two terms, both terms have your variable x or whatever that variable might be in the problem. So find the derivative of h of x equals 3x minus 2x squared times 5 plus 4x. So again, we have an h problem. It's split into two groups here. We have the 3x minus 2x squared group times the 5 plus 4x group. This is a product rule situation. To do that again, it's going to end up being h prime equals the derivative of the first part. So the derivative of 3x minus 2x squared is 3 minus 4x times the second part unchanged, which is a 5 plus 4x, and then it's always a plus the derivative of the second part. The derivative of 5 plus 4x is going to be a number 4, because the derivative of a number is 0, 4x is 4, and then multiply that by the second part, the first part unchanged, 3x minus 2x squared. And that is the derivative. Derivative of the first part times the second part unchanged plus derivative of the second part times the first part, unchanged. Here they'd probably clean this up a little bit. I'm going to FOIL out this group. That's going to give me a 15 plus a 12x minus a 20x minus a 16x squared. Distribute the 4 in, so plus 12x minus 8x squared. Combine some like terms. Negative 16x squared, negative 8x squared is negative 24x squared. Plus 12x, take away 20x, plus 12x is going to be plus 4x. And then the 15 constant. Negative 24x squared plus 4x plus 15. Did we have to use the product rule for example 1? No, we did not here. We could have FOILed that out originally and taken the derivative of each piece. We could have FOIL first, then derivative. Could have done it that way. That probably would have been easier on this particular problem. That's what we taught you last week. Groups aren't great for that case. But sometimes you can't do that. Sometimes we have to utilize this product rule. And that's what these next few are going to be about. So again, find the derivative of each of the following. Well, we have f of x equals x times the sine of x. So again, there are two distinct pieces here, x and sine of x. Each of they're multiplied together, x times sine of x. They both have the variable. I can't really FOIL distribute this to break it up. I have to utilize this product rule. Again, that's going to be f prime of x is the derivative of the first part. The derivative of x is a 1. Multiply that by the second part, unchanged, which is sine. And then always add, always add the derivative of the second part. The derivative of sine is cosine times the first part unchanged times x. So this is going to end up simplifying, cleaning up a little bit, and we get f prime of x equals the sine of x plus x cosine of x. Example B here. Again, this has to be a product rule because I have e to the x times x. Each piece has its variable. So this is definitely a product rule, e to the x times x. When I work this one out, I'm going to have g prime of x is the derivative of e to the x, is the easiest derivative, it's just e to the x, times the second part unchanged, times x, plus the derivative of x, the derivative of the second part is a 1, times that first part unchanged, e to the x. So we get e to the x times x plus 1 times e to the x, or clean this up a little bit, g prime of x is x e to the x plus e to the x. All right. Example C here. Be careful on example C. We definitely have a product rule. 2x cosine x multiplied together. 2x is a piece, cosine x is a piece. Both have x, they're multiplied. The second half is not a product rule. 2 sine x, there's only one x term, one variable term in this group. That number 2 is a constant. We don't have to utilize the product rule for that. So that's going to be a basic derivative. This is going to be h prime of x equals, again, 2x. The derivative of 2x is a 2 times the derivative of, times the second part unchanged, times cosine of x, plus always a plus sign in the middle, plus the derivative of cosine is negative sine times the first part unchanged, times 2x. And then the derivative of minus 2 sine of x. The derivative of sine at the end of the problem is cosine, minus 2 cosine x. If we clean this up a little bit, we're going to have h prime of x is 2 cosine of x, plus a minus makes a minus in the middle here. So it's going to be a minus 2x sine of x minus 2 cosine of x. If I pay attention, 2 cosine x, take away 2 cosine x, those actually cancel out. And we end up with h prime of x is negative 2x sine of x. So I had a product rule with this 2x cosine x because I had two x values multiplied together, and then a subtraction sign separating things. Addition and subtractions always separate terms. A separate problem of 2 sine of x, which is just a normal derivative from the other day. And finally, D here, k of x is x squared ln x. I have x and x, going to have to be a product rule. It's all multiplied. X squared is the first piece. Ln of x is the second piece. So our overall derivative, k prime of x, the derivative of x squared is going to be 2x times the second part, unchanged, times ln of x, plus ln of x. The derivative of ln x we discussed last time is always 1 over x, 1 over x, times first part unchanged, x squared. So that gives us k prime of x, 2x ln x, plus 1 over x times x squared over 1 over x, or excuse me, x squared over x. Reduce this down to just give us an x. 2x ln x plus x. We're in good shape. All right, product rule again, multiple x's. Another way they love to throw these product rules at us is to give us a chart-like problem like this. It takes the algebra away and it really focuses on, do you understand your calculus skills? So let h of x equal f of x, g of x. Again, we have x and x, multiple x's. Things are multiplied together. We have an f of x piece and a g of x piece. This is going to be a product rule. Find h prime of 3. Find the derivative of h at 3, where h is the product of f and g. Well, to make this roll, we're going to have to figure out what is just basic h prime. H prime is, well, f of x is going to be f prime of x times unchanged g of x, and then add on the derivative of the second part, g prime of x, times unchanged f of x. First part derivative times second part, plus second part derivative times first part. From here, we can put 3 in for all the x's. H prime of 3 is f prime of 3, g of 3, plus g prime of 3, f of 3. Now, I go to the chart to find these specific values. So h prime of 3, f prime of 3. So f prime column, 3 for the x. Those come together to give us an 8. G of 3, regular G column, 3 for the x, come together to give us a -4, plus G prime of 3, G prime column, 3 for the x, that's a -4, times f of 3. Again, f column 3 is a 1. So 8 and -4 is -32, plus -4 and 1 is -4. That gives us h prime of 3 equals -36. Okay. And then last, find d dx. Again, this symbol, d dx, means find the derivative of radical x times f of x when x equals 4. With this, radical x, remember that's an x to the 1/2 power. We don't like radicals. Times f of x is what we're looking at here. We could call this y equals. That's our function. It is a product rule. We have two x's going on here. X to the 1/2, f of x. Two different things multiplied together. Find this derivative. Find y prime. Well, x to the 1/2 power, first part. 1/2 comes to the front. X, subtract, -1/2 times the second part, f of x unchanged, plus f of x derivative is going to be f prime times first part unchanged. I can clean this up a little bit. I can put x -1/2 in the denominator. 1/2 x 1/2 times f of x plus f prime x 1/2. And if it helps at all, we can change a 1/2 power into a square root. So 1/2 radical x times f of x plus f prime of x times radical x. I want to do this when x equals 4. So we're going to do y prime when x equals 4 here. So 1/2 radical 4 times f of 4 plus f prime of 4 times radical 4. All right. We can find these now. Radical 4, we can calculate that. That's a 2. 2 times 2 is 4. 1/4 f of 4. F column 4 for the x gives us an answer of 10. 1/4 times 10 plus f prime of 4. F prime column 4 for the x gives us an answer of -1 times radical 4 is a 2. Simplify this. 1/4 times 10 is 10/4 or 5/2. -1 times 2 is -2. 5/2 minus 2 is 1/2. So solution of 1/2. All right, guys, that's product rule. We got to use this when we're multiplying two terms together. Key thing is both those pieces have a variable involved. Derivative of the first part times the second, plus derivative of the second part times the first. Hope you're all doing well.